So this video is about deciding on whether a real number system statement is true or false. So I have two different strategies that we can use for this. The first one is using the real number system diagram, and the second is thinking of a counterexample. So when I say a counterexample, like for the first one, it's saying all integers are negative. If you can think of one integer that's not negative, then you have your counterexample, something that makes this necessarily false. Okay, you can use that with strategy one. We can use these two strategies together. On the front side, it's just easier to use the picture, which is the diagram of all of the subsets of the real number system. So all of these fall under real numbers. That is basically the rational numbers plus the irrational numbers. Inside of rational numbers, we have integers, whole numbers, natural numbers. This graph is going to be really useful to decide if some of these are true. Okay, so you can use these two strategies together. On the front, I'm almost exclusively going to use the diagram. On the back, I'm going to try to just think of one counterexample. So the first one says negative 15 divided by 3 is a rational number. I don't really want to decide on it like that. I want to decide the answer to this. Is that a rational number? So negative 15 divided by 3 is negative 5. I want to decide, is negative 5 a rational number? The best spot for that, it's really a negative whole number. So the best spot for that would be the integers. So now I have to decide, is that also a rational number? Well, the rational numbers are on the outside. That's this big box. The integers are all inside of the rational number. So if it's an integer, then it's got to be a rational number. That has to be true. Next one says some integers are whole numbers. So is that true? Some integers are whole numbers. Well, we can use this one as our first example. Is negative 5 a whole number? Well, it's a negative number, so it can't be put into that one. It's just an integer. It can't be put into any of these smaller groups. But let's think of some whole numbers. The easiest example of a whole number is 0. That's going to go into that group. Some integers are whole numbers. Well, this is one example. 0 is in the integer box, so it's an integer, and it's a whole number. There are definitely some integers that are whole numbers. 0, 1, 2, 3, they all fit into natural numbers. All of those are integers that are also whole numbers. So that's also true. The third one says 3 to the negative second is a rational number, but not an integer. 3 to the negative second, we can plug that into the calculator. We hit 3, and then we hit the y to the x button, and then we can type in negative 2. It would give us a decimal 0.11111 repeating forever. That's a repeating decimal. So that is a rational number. Actually, that's the best spot for it. Integers don't include any decimals. Rational numbers include the decimals that repeat forever. Irrational numbers include the decimals that go on forever but don't repeat. So this one's a repeating one. That means it's in the rational numbers group, but it's not in the integer group because integers don't include decimals. They only include positive and negative whole numbers. So that is also a true statement. Use this diagram to try to decide on each of these next 4 questions. All right, on the back, I'm going to go over 3 examples also. So the first one's saying all integers are negative numbers. Can you think of any counterexample? Think of an example that makes this false. All integers are negative numbers. So the first integer I think of is negative 1, then negative 2, negative 3. Those are all negative numbers. But I have to remember, again, kind of using the diagram, everything that's in the whole numbers group, 0, 1, 2, 3, those are also integers. Anything in a smaller group is also a part of the integers. So these are the integers. There's obviously more, but this is saying that all of them are negative. That's definitely false. We have some positive numbers in there. Second one says rational numbers are always repeating decimals. We can see from the last page that's true. Sometimes it is. We have repeating decimals in rational numbers, but negative 5 is actually also a rational number. It's in the integers group, which means it's a part of the rational numbers. Negative 5 is not a repeating decimal. It says rational numbers are always repeating decimals. That's false. Negative 5 is a rational number, but it's not a repeating decimal. 0 is the only whole number. This is a misleading one. 0 is the only number that will go into this group, into the whole numbers group, but it's not the only whole number. 0, 1, 2, 3, 4, going on forever, those are also whole numbers. The positive numbers that don't have decimals are natural. That's the best spot for them. But since they're in the natural numbers, they're also a part of the whole number group. So that's false. 0 is not the only whole number. It's the best example of a whole number, but it's not the only one. Number 4 says the sum of a rational number and an irrational number is rational. Let's try an example of this. Let's do pi plus 10. That's an irrational number, pi, plus a rational number. That's what this is saying. The sum, the addition of a rational and an irrational is rational. Well, this would give us something like 13.1415926, going on forever with the same digits as pi. It's a decimal that's going to go on forever, and it does not repeat itself. Just because we added 10 to it doesn't mean it's going to all of a sudden repeat itself or stop. It's still going to be an irrational number. Actually, this one's also false. It's going to be an irrational number. Alright, complete the rest of those on your own. Again, try to think of one counterexample that either makes it true or false, and it should help you. Again, you can use the diagram with that strategy.